Alright, so it's question 10. Which of the following pairs can be used to illustrate the law of multiple proportions? So in chapter 2, where there's few laws, there's like 3 laws you had to kind of know, right? One of them was the law of conservation of mass, and I can't really remember all the other ones, but one was the law of multiple proportions. It has to deal with compounds with 2 types of elements in it. So in this question, the only 2 compounds that have the same elements in it are SO and SO2. So this is the answer. And question 11, how many of the following postulates of Dalton's atomic theory are still accepted? So let's look at 1. All atoms of the same element are identical. So that's false. We know, like I said, we could have ions, so plus or minus electrons. Oops. We could have what are they called? Isotopes. Or heavier atoms with more neutrons. So basically that's false. The second one, compounds are combinations of different elements or different atoms. So we know that's true, right? H2O or any other compound is just, you got your element H and your oxygen, so it's just made up of 2 different elements, or different atoms, 3 different atoms in this case. 1, 2, 3. A chemical reaction can change the way atoms are grouped together. So we know that. We have a few examples of different kind of chemical reactions that could happen. We could have this. Remember, that's a single displacement reaction. So that one's true. It just changes chemicals around. 4, atoms are indestructible. So this is false. And I mentioned this in class. We got the, I don't even know what it's called, CERN laboratory. Once again, I can't spell. It's breaking up into smaller pieces. So electrons are fundamentally small piece of an atom, but protons and neutrons could actually be broken down into even smaller things. And like I said, I did do this question in class. Which of the following statements about atomic structure is false? This question I also covered in class. Which of the following? So let's look at this. So A, atom is mostly empty space. Remember, you have your electron floating around, and your protons are in here. Protons and neutrons. When you look at it, it just looks like a big sphere, right? So remember, it's just this electron density cloud. So it's kind of big, but really your electrons are just tiny, your protons are tiny, and everything around it, like any kind of matter, like a desk or anything, is mostly empty space once you get down to an atomic level. And remember, it's like saying golf ball. The size of an atom is like golf ball, and this is like a stadium. So a golf ball within a stadium kind of represents how big